The purpose of this video is to help you find domain and range and express your answer in the correct format. Go on to slide 2. First, let's go back to what the definitions of domain and range are. Domain is all of the possible input values. One helpful way to remember this is the fact that domain actually has the word in right in it, in input. Domain is telling you all of the possible numbers that typically the variable x can be, because x is normally the input. Range is all of the possible output values. So range would be all of the possible numbers that typically the variable y can be. Move on to slide 3. The answer for domain might look something like this. 0 is less than or equal to x is less than or equal to 7. That would mean that x can be all of the possible numbers as long as it's 7 or less or greater than 0. So x could be anything between 0 and 7. X could be 1, 2, 3, 4, 5, 6, or x could even be those fractions and decimals that are also in between these two numbers. Some numbers that x couldn't be are 7.1, 8, because those are bigger than 7, and x also couldn't be anything negative because those numbers are less than 0. An example of your range might be -4 is less than or equal to y is less than or equal to 12. This means that y can be all the numbers that exist between -4 and 12. And since it has or equal to, it can also be these two numbers. So y could be -4, -3, -2, -1, and so on until you get to 12. Also all those fractions and decimals that are in between. Y wouldn't be allowed to be 13 because that's bigger than 12, and it also couldn't be -5 because that's less than -4. Go on to slide 4. Occasionally when you're being asked to find domain and range, you're not given the variables x and y. So even though domain typically describes x, in this particular problem, we would need to decide when describing domain, am I really going to be describing t, which stands for temperature, or d, which stands for distance. To do this, we use the idea that in every function, y depends on x. So in this particular problem, we have capital T for temperature and d for distance. The fact that temperature depends on distance means that if you just match them up, that t can really be thought of as y, and d can really be thought of as x. That's important because what that means is that when you're describing domain, instead of describing x, you're really going to be describing d. And when describing range, instead of describing y, you're really going to be describing t. So now it's time to actually find the domain and range. We already talked about that when describing domain, normally it's x, but in this particular case, it's distance. So we're trying to figure out all the possible values that you could have for distance into the Earth's crust for this problem. Essentially what we're trying to find is the highest number that the distance can be and the lowest number that the distance can be. The lowest that you can drill into the Earth's crust is 0, because if it was negative, that would be drilling kind of above the surface of the Earth. That doesn't make sense. And then the problem tells us the restriction on D. It says that the scientist plans to only go 4 kilometers deep. So he's not going to go beyond that. To find the range, we have to do a little more math. So we actually have to figure out what is the temperature at each of these spots. We can do that by using the equation they gave us. So the first thing we can do is find the temperature when the distance is 0 by replacing D with 0. If we did that, 25 times 0 is 0, and then add that 20. So the temperature when you're 0 kilometers in the Earth's crust is 20 degrees Celsius. Now we can go back and do the same thing and find the temperature when the distance is 4. So now I'm going to take the number 4 and replace it with D, or replace D with it, and follow order of operations. So 25 times 4 would be 100. Add that 20, so when you're 4 kilometers deep, your temperature is 120. So what this is telling us is that the distance has to be between 0 and 4. Again, we can't drill negative, and you're not going to go beyond 4. and that as long as the distance is between these numbers, the only possibilities for the temperature would be between 20 and 120. In the previous example, they pretty much had given us the domain. They told us that the scientist was planning on drilling between 0 and 20. And this time they're telling us that the scientist is planning on going between 20 and 95 degrees. So this time they're telling us about the temperature. So they're really telling us the range. And they're saying that the temperature has to be less than or equal to 95, but the temperature also has to be greater than or equal to. And if you read it from right to left, it says greater than or equal to 20. So they're giving us the range. The thing that we're not sure about is at what distance do these temperatures occur. So to figure that out, in this equation here, T equals 20 plus 25D, they're not telling us the distance anymore, they're telling us the temperature. So we can actually take these numbers and plug them in for T. So the first number I could replace T with is 20. So I get 20 equals 20 plus 25D, and I would solve that like a normal equation. So I would do that by minusing 20 from both sides, and then dividing by 25. And if you do that, you're going to get 0. So now I know that when we're 20 kilometers, or sorry, when the temperature is 20 degrees Celsius, that occurs at 0 kilometers. The next thing I have to figure out is what's the distance that goes with 95 degrees Celsius. So to do that, I would replace T with 95, and then solve for D. Sorry, that's a 20 plus 25D. So you'd minus 20 from both sides, which is 75, and then you would divide by 25, and you would end up with 3. So in this problem, you were really given the range, and we were able to find the domain by plugging in.